welcome to our community. Feel free to put in the chat if you are not shy where you are connecting from right now. So we know each other. We create that kind of relationship that we expect for our community. I would love to hear from all of you where you are connecting from right now. And of course, feel free to start the chat, asking question, even if this is not the main topic that we are discussing now with Mathias. If you want to hear more around different aspects on Power BI experience, projects, industry solutions, feel free to connect with us, connect with Wes, Andrew, Alina, Ross, and let us know if you want to hear more around any practice around Power BI, any combination around Power BI and external tools, or anything that comes to Power BI. This is the kind of the main goal for us in this community, is to listen to our community and try to leverage more kind of speaking and opportunities for all of us here. Remember, we don't need to be an expert to jump in and talk and discuss and share with community. That's kind of a meaningful thought from our community. We are just Power BI enthusiasts here from the Seattle hour. We are more in the west side focus, as we mentioned here. We love Power BI. We love different technologies. We love all the combination between Power BI and different technologies. We love the migrations from other technologies to Power BI. We talk about that a lot. We meet with people from different countries, from different time zones. I am really glad to see all the comments and all the chat interactions right now. We have people coming from Olympia, Seattle, Portugal, Denmark. It's amazing to see that. And the main goal is kind of start sharing about our journey. Be visible in these kind of cases, not a code of conduct here, just be friendly, be patient. If you want and you desire that, go and mute yourself, talk with the community, go on camera. I love to see all the funny faces here and interacting between all of us. Go ahead and feel free to reach to us if you want to participate. How to get involved? Provide feedback. That is really meaningful for all of us as speakers, as a user group leaders. It's really amazing to receive the feedback on how we can do better. Recommend speakers, jump in, and if you have a really good story or you want to share your knowledge, your projects, your experience landing projects with Power BI, would love to have you as a speaker. We don't need to be MVPs or leaders to speak in, to jump in, and to share our knowledge. That's pretty much the message here. If you want to participate with us, just reach to Wes, Andrew, Ross, Alina, and we have multiple options in terms of participation with our community. Today we have Mathias. We met last week in person here in Seattle, and feel free to jump in. I don't know, Ross or Alina or Andrew, who is going to present Mathias. I love to any one of you jump in and present Mathias into this community.
Like I said, Gaston's met with Mathias last week here. So yeah, really excited to see some more details on Synapse with Power BI. I know there's a lot of chatter about that at the moment with kind of some of the new integrations and seeing what's coming out later this year with all the platform online. And I know there's been talk recently about one of the latest updates of Power BI is the discussion around being able to actually edit the data models within the Power BI web apps. So I think that leads nicely into a discussion around Synapse and Power BI living and breathing and being one happy family together. But in the meantime, be sure to take a look at Mathias's website as well as his Twitter and LinkedIn. Always some great material out there, and really excited to see what he's got to share today.
Cool. Thank you so much for the introduction. So let's talk Azure Synapse and Power BI together. Everything is good. People see my screen and all is fine. I'm getting some nods, so that's good. Right, so let's get started. I assume we have a little short of 1 hour for this, for questions and everything. Someone thumbs up? Yeah, or 45 minutes?
Yeah, about 45, and then a few minutes at the end if we've got questions there too.
Yeah, that's
feel free to everyone can feel free to drop questions in the chat as well, and we can take a look at those as Mathias goes as well. If you want to jump in on voice.
And since it's a user group, feel free to jump in during the presentation, and I'll try to not let it derail too much. But yeah, feel free to open up for discussion and debate and questions and everything. So we're here to talk about how you use Supercharge Power BI with Azure Synapse Analytics, and I have one goal today. And let's see at the end of the session if I achieved it. I want to convince you guys that Synapse is powerful. I want to convince you that it is approachable, something we can actually do. It's not very big and very daunting. I want to convince you that Synapse is the answer when we talk about a unified data platform for our backend. And I want you to be convinced that Synapse and Power BI together is an unbelievable combination of the best of both worlds. So I hope you are, with that in mind, excited for us to get started. My name is Mathias Halkjaer Petersen. I work as a principal architect in data analytics at a company called Fellowmind. I'm, well, at the core, a data enthusiast. I'm a Microsoft MVP, actually very recent Microsoft MVP, young kid on the block. I was trained in product development and innovation, and I think that brings me a unique viewpoint to how we do BI in general. And I like to not focus too much about the technical things or too much about the actual data itself, but more think of it as a solution to a problem that adds value. And we need to find out how we add the most value, and data is our product. Anyway, that being said, I definitely also have had my fair share of working with data warehousing, working with Power BI, working with everything in between those two. Aside from that, I am a parent, a foodie, a casual gamer when I have time, which means never. But one day I hope. Once in a while, a favorite game of mine will release. I'll put it aside 1 week and then do nothing else than playing that game, and then back to waiting for the next thing. And of course, a tech aficionado, like in anything new, and currently very keen on learning more about ChatGPT and OpenAI in general. So my favorite tools are Synapse Analytics, Power BI, and Azure SQL, of course. So today we have to talk about not just one, but two of my favorite tools, which I really like. So that is great. On top of that, I have a website, as was told earlier, but I also host 2 monthly quizzes, a Power BI quiz and a data platform quiz, each covering each of the areas around data, one for Power BI, one for Synapse and everything in between. Yeah, I think that's me. So if you ever want something chill that is still around data, go search for the quizzes. They are quite fun. Anyway, enough about me. We are here to talk about, there's more about me. So sometimes people ask me, what do an architect do? Well, we do blueprints like this and make sure that the platforms work the way the clients want them to do. Basically, maximize value based on the tools we have at hand. If you ask my kid, I'm pretty sure he would say that dad draws for a living. And I think he'd be right at that. That is doodling for a living. I think that's basically it. Anyway, onwards from me and talk about you guys and these 2 favorite tools of mine. So Power BI and Azure Synapse Analytics. What are these? How do these 2 work together? So aside from convincing you that how powerful they are together, I am also going to show you how they interact, how they're integrated, and how we can make them play with each other, or what you say. So in today's realities, we all have kind of the similar problems with understanding what data we have, making sure that our data is trustworthy, or understanding if it is or isn't, make sure the right people can access the right data at the right time when they need to make the right decision. That was a lot of rights. And of course, being able to do this at scale and at a speed that makes it valuable. And finally, without overstepping some legal boundaries or otherwise morally problematic things. So basically, yeah, data, data quality, data access, quick from end to end, and legal, and well, all in all, good. So that's easy to say, but how do we do it in practice? Well, we are kind of a different place today than we were 5 or 10 years ago. So to understand today, I would like to go just a bit back in history and talk about what things used to be like. So we used to have a different problem than we have today, because back in the time we had businesses that had data, and we had an enterprise that needed data, and then we had other businesses that also needed the data. But the problem was that if one business had data, they may have needed, and when I say businesses, I mean, business department, so business area. So sales may have data, but they need data from finance. They need data from product, the product department, from engineering. And they need and those teams need data from business. So all of these teams, of course, need a way to share the data. And back in the days, two clever guys realized that, well, if we collect these data in a central repository, we can suddenly share data more freely. So suddenly sales can put in the data to the enterprise layer. So could engineering, so could finance, so could everyone else, and so on. But a new problem kind of arose, was that the way they used the data was different. So the way the finance want to use the sales data is different from how the sales people want to use the sales data, and so on and so on. So again, we had a problem of differing needs. And that's where two of the kind of founding fathers of the data warehouse came up with a very similar, very identical concept at almost the same time. They both invented the term data marts. So data marts that allowed us to take our big conformed mass of data and turn it into that last step, transform data that we actually need in our subdivisions. And this is a pretty neat pattern that was invented back then. So a lot of technology was on a lot of architecture and technological implementation was built around these kind of patterns. And the tools that were used for that back in the days were SQL Server, often SQL databases, often something like SQL Analysis Service, as well as something like SQL SSRS, so SQL Server Reporting Services. And it was very much IT driven. So people had to deliver the data to IT, and they had to ask, pretty please, can I have some data back that I need for my reporting needs? On top of that, the tools were expensive. They were complicated to implement. They were slow because IT was a bottleneck. And yeah, IT became the hugest bottleneck in back then. So this was only possible for the most important decisions in the company. It was only possible for the very most important people in the company. And it was only possible where the return on investment was significantly high, because the investment to even reach the point of making a report and making a data set was very significantly larger back then than it is today. Because today is different. Power BI entered the picture, and suddenly we had two completely new ways of doing data analytics. We had the completely business-driven way, where people can just tap into the data source directly from Power BI, load in the data, model it quickly, analyze it, and within a few hours or even just a day, you are able to go from data source to having your first insights. Of course, the IT is still wanting to be in control of the data in some way, and there are still places, but mostly the places that used to have a data warehouse, so they could just build Power BI on top of that. Well, they still want to utilize the data warehouse within the context of Power BI, which makes a lot of sense, and as I hope you will learn shortly after here. So we have this hybrid that Power BI kind of, well, it's been said many times. Power BI democratized the world of BI, and with the good and the bad that kind of entailed. Yeah. So Power BI is great. I think that's no news for everyone here. I think we all agree on that, and I could probably have said that from the very beginning, and you would all have nodded. Power BI is great, but is it great for end-to-end analytics? That is the question. And I'd like to start with talking about what we have, or at least what we had before the introduction of some of the more recent capabilities. So we had a data set, we had a report, and we had sharing. And that was it. So we could go build a data set. We can make one or more reports based on the data set, and we could share that data set. And that is as we talked about before the session, that is the real life for most people here who are using the basic pro features of Power BI. Yeah, and that's good, but it doesn't really cover the missing pieces. So there are, if you ask me, some missing pieces that Power BI doesn't really solve today. One of them is what I would like to call source load minimization. It probably has some other technical term that I should know about. Doesn't matter. When we start loading data from Power BI, we of course send a query to our source database. That source database is using a little bit of compute late making that query. Well, if we're loading the entire database of all tables or something, of course that little compute is going to be a significantly large compute, large consumption on that database. But if we then add the fact that people are creating more than one data set and it's created across the whole organization, and some may even create some massive data ingestions from this source, like full tables, all columns, 300 columns, multiple millions of rows, hundreds of tables, I don't know. I've seen stuff like that before. And then on top of that, other people may do inefficient query that has to hit that database 3, 4, 5 times or more. Then you start having a source database that starts struggling. And in worst case, if you haven't set up proper guardrails, it will crash and it will become slow and will become laggish. So we need some sort of intermediate layer to handle that source load. So the other problem is around enterprise conformity, because we already talked into this kind of diamond-shaped data sharing thing. If businesses for proper sharing needs to hand up to enterprise and then use it again, because that is a neat way for them to be able to share with each other, well, when Power BI enters as some sort of loophole, black hole that just makes the business able to solve their own data needs without involving enterprise, so sales can do their own reporting based on sales data, and they don't really need central BI or central IT, well, then they're going to have problems with sharing that data with others and may have trouble finding the data from the other departments that they need. So there's a layer of enterprise conformity that is lost in the middle of all this democratization. And this is probably what people often refer to as the lack of a single source of truth. Because what will happen is that we will have 5 definitions of what is a customer, 10 definitions of what is a product, and so on and so on, which is hugely problematic. But it's not an unsolved problem, because we solved this already back in the 1970s, long before I was even born, if I need to be honest, which is a bit wild for me to think about. But anyways, it was solved before, and we kind of had these standard steps of what needed to be there for a proper data platform to function well. And that was a layer where you did ingestion. I think most of when the concept was coined, they called it staging. Terms, can be used interchangeably, but we need a way to load in the data. So we need some sort of ingestion of the data. We need a layer where we could do data quality and data cleaning to make sure that the data becomes more and more pristine. And we need a layer where we can curate this enterprise data that is data modeled in the way we want it shaped, and can share this with our respective departments. I saw someone take up a hand. Did we have a question? Guess not. Feel free to interrupt if you have a question. So we're lacking these things, and these some of them partially, as you will see soon, some of them are partially solved in Power BI today. But they used to not, and I would say there's still a lot of them that aren't. So we have an ingestion. We load data into the dataset, but we never materialized our one-to-one data the way it looks at the source, which means we do a lot of filtering, we do a lot of graining, or what do you say, raise or lower the grain of our data. We do a lot of transformations that kind of every time chip away a little of our initial data, which means we never get a copy of our original data, preventing us from doing historical analysis on that data, preventing us from using the data in its raw form if we have needs for that, and so on and so on. We don't have a dedicated layer for cleaning. Yes, we can do transformations like remove nulls or change some sort of invalid things to null, or detect if things are not living up to the format we want. But after we have done that in Power BI, we just cleaned it, but we never fixed the root cause of what caused the bad data quality. We never found out that, well, I should probably inform the guy who entered this into my system that we have this problem with the data quality for these entries. Power BI just doesn't have a proper way of handling workflows like that. And finally, curated data. Well, before the tools we got, like the last 1 or 2 years, we only had the data set, and that data set was very much the model, so we could use it as a curated thing, but only if it was very strictly governed by IT and kind of made one big data set or something like that. In a lots of ways, it was not very flexible, and it didn't open up for any sort of data mart thinking. So, and finally, sharing data outside of Power BI was kind of a no-go. This was locked down, total vendor login, which of course can be not a bad thing if you're only using one tool, but if companies want to use other tools for reporting or for their data, they just didn't have a way to pull it out of Power BI. But we did get new things. One of them being the data flow. And where exactly the data flow fits in here and what it solves is kind of some of it and maybe all of it, but maybe not always in the best way possible. And what I mostly see it's used for data ingestion. We had data sets that could then refer to other data sets. Actually went GA this month, the composite for Power BI datasets and analysis service models. Power BI, yeah, I never remember what that feature is called. Too long.
Hey, Mathias.
Yeah.
I have one question from Harry that this could be a really interesting question. And Harry was mentioning ETL, now ELT into data lakes, and what about Azure Data Factory? I would love your thoughts around when data flow, when data factory.
That is a good question.
What is your take about that? I have my own opinions.
Yes, I'm actually going to cover an example with Data Factory in the session as a demo. So can you please remind me, if I don't cover it there, can you please remind me to ask this question again at the end of the session, because it really makes sense, but I want to keep it for when it's even more relevant. But it's a very great, very interesting question. Good. So we got the data flow. We got the data set that can now be used as a source for other data sets. We even got REST API access to the data set, so we can now pull data out of the data set. Except you need to know both DAX and know programming and know, a lot of things to make this happen. So not a very easy way to get the data out. And what is a very easy way to get the data out today that a lot of people use? It's called export to Excel. Yes, which is of course not ideal. We also got data marts, and yeah, I still think we can still call it new. It's still preview, so it's still new. Data mart maybe is the closest thing we will get to an actual curated thing in Power BI. It's very much fills that role where you can load in the data. You can have a SQL endpoint that helps you query that data out of the data mart. You can suddenly share it. You can be flexible. You could even use a data mart and another data mart as a source for each other, and you can start doing some of the more data warehousing kind of things with the data mart. But still, even with data mart, it's not really a full picture. There were still things lacking, and I would say especially around something like historical data. So there are still problems left. What are the problems? I still believe we have a kind of an out-of-sight transformation layer. Even if we load it into data flows, we load it into a data mart, load it into Power BI, there's a lot of steps here where the data gets a multitude of transformations, but it can be hard to audit how exactly happens at each step, and then also hard to send those potential problems back to the user who needs to know about them. Whereas in a data warehouse, you are more strict on we do one transformation layer, then we have some output we can audit, we can monitor, and we can report back. Then we do another layer of transformation and the same. So here it is existing. We do transformations, but it's kind of black box-y in a sense. Not always the best tool for data warehouse tasks. I think I already commented on that. There's no logs or output from cleaning or quality checks. And also it doesn't have handle humongous data very well. There is, of course, a limitation in Power BI data set size. And if we go beyond that limitations, we are going to need something like Azure Synapse. I mean, we need a data warehouse. We need a backend to store the data. And then we can play around alternative like composite models with direct query and stuff like that. But even to make that work, and they were really great features, but to make them work, we need a backend, a proper backend, data warehouse, data lakehouse, data platform, all these things. We need something like that to make these enterprise features work. So what is it exactly that we get by adding Azure Synapse into this mix? We get, and the session is called Supercharge, so this will of course be superpower themed. We will get time travel capabilities. So we would be able to do proper historical data and change tracking. We could store snapshots of how data looked week over week, month over month, and don't have to care about if our source systems are overriding these values. My favorite example is project data, which often has some sort of deadline field. And for some reason, all the project data sources I've had to work with, they all do the same thing where when you change the deadline during a project, it's just overwritten in the database layer with no history of how that deadline moved. So a project that was a year over time, it looks like it was on time because the deadline was moved along the way. With historical data, we can actually track this and we can document it and we can make reports that show how the deadline of such a data field actually moved over the course of a project, which is really powerful and something that a lot of people forget to think about because they don't always think that historical data tracking is even possible. So we can have more data in our data platform than our source systems allow for. Really powerful and really opens up new facets of analytics. So supersize. Synapse handles massive scales of data, and it handles it incredibly fast. Something like the serverless pool in Synapse, it was the first and I think still the only tool that passed some benchmark for petabyte scale data. So really great for massive large data. Then we have reflection, which is reverse ETL. So if you ever had a customer, if you ever had a user say, but this data set data is great, I want to use it for back in my CRM system, or you want to use it for a web application, or I want to use it for a customer-facing product something. Well, it's kind of difficult to pull the data out of Power BI as it is, which is what reverse ETL is. I really hate the phrase and it's very hyped, but that is what people call it. It basically means pulling data out of your system again. It used to be an anti-pattern, and I think to some extent it still is, but it's also something that can be very valuable in the right scenarios. So it's definitely a capability we should acknowledge. Then we have multi-power, one of my favorites, because what we get in Synapse, especially with Synapse Spark, is the support for multiple programming languages. So suddenly, if we want to do advanced data quality checks or advanced data quality management, we can start using libraries in Python, like Great Expectations is one of them is called, but it's the same for all kinds of areas. So we expand our capabilities not just to a new tool, but to a new language that has so many libraries and so much community, basically community power that we can then utilize. It really opens a whole new world of what we can do with our data. And that comes through the support for Python in the Spark engine. So we can do Python, we can do C#, we can do SQL, we can do Scala. I think that's it. Probably I always forget one of them. But basically we can do, if one wants to call it real programming, but we can do actual like bespoke programming together with still doing SQL-based transformation. We can still do UI-based transformations and stuff like that. So best of all worlds. Hypercognition, of course, there are more AI capabilities in Synapse than Power BI. We go beyond just having access to cognitive service and stuff like that, and can actually start making systems where we can train our own AI models that can then in turn be used for Power BI. So again, they neatly tie together. And finally, we have regeneration, which is not the most sexiest, but probably the most important of all of them, which is proper CI/CD and version control. We can, with a few clicks, we can sync up our Synapse to a repository in Azure DevOps or in GitHub. And by doing that, we have full control over what changes are made to our data pipelines. And along the way of that, we make sure that if something goes wrong, we can track it and we can turn back time and do a formal version of our pipeline. Of course, these capabilities are equally important in Power BI. It's just that it is more critical for where our data mass is. So moving our data mass to a backend that's made for handling big data systems like this gives us more power over our data estate in respect to versioning and stuff like that. So those were the superpowers. I hope that at this point you're starting to see at least some hints of why Synapse can help with together with Power BI. So that was the end-to-end in Power BI. How about the end-to-end scenario in Azure Synapse? And before I get to that, I want to talk about what is Azure Synapse. Because Azure Synapse is, as many misunderstood, it's not a tool, it's actually a toolbox. So out of the box, we get so many things. We get pipelines, we get data lakes, we get serverless SQL pools, we get dedicated SQL pools, we get the Spark engine, we get Synapse links, and we get lots of things, lake databases, mapping data flows, etc. So many different tools. And I'm going to skip this briefly. So yeah, there's a list of a bunch of tools, everyone doing their own thing and doing what they do best. I want to skip to a point where I say you starting with Synapse costs $0 per month, which means you should not be too afraid of this becoming very expensive. If you know and you've researched what you're doing, you can actually make really cheap data platforms if you do it right, at least if you have low to medium amounts of data. Of course, it's an Azure service, so the sky is the limit, which can be a problem because potentially you could also have it way more expensive than you planned. But it is starting at $0 initial cost, which is, I think, the thing that scares people away from trying it the most. They think that they have to pay tens of thousands of dollars to just even get started. And you can do that if you just pick the biggest tool in the toolbox. So in that whole deal, let's talk data lakes for a bit. So we had the questions before, ETL versus ELT, and one of the things in that question is, why should we use data lakes? And we should use data lakes. People forget to say this. We should use data lakes because they're cheap. They are like a factor 10 cheaper than storage on a SQL database. So it is by far the cheapest storage we can ever get. It's like, I think it's for 1 terabyte of data, and a terabyte is a lot. We pay around $20 per month for that kind of storage. So very, very cheap compared to other offerings. And it makes it excellent for landing zone in the cloud. It's the same pattern used in all the different clouds. It has redundancy features like geo replication and stuff like that. Great for quick and dirty analytics as well. And well, it can, with the right data formats, it can have excellent data performance, and often offers also the most efficient way to load data into the data warehouse. And finally, it is in a format that can easily be consumed by any modern BI tools. So we will go back to the ELT versus ETL question now here. So I can see I'm running a bit out of time, more quickly than I hoped. So I will skip briefly over the question. So when we load data into a data warehouse, we have to put it in boxes. And what I call boxes is stuff like table schema, granularity, column choices, stuff like that. We choose a chunk of the data and we put it into a neat box because that is what fits into our data warehouse. Which means we're cutting away data. We're chipping away data that we don't need, but that we cannot know for sure if we are going to need in the future. And that is really, if you ask me, the biggest benefit of ELT is with ELT, we just load the data into the data lake as it is without chipping away anything, without putting it into some fancy box, and just loading it into the data lake, which of course creates more data. But again, data is ridiculously cheap in the data lake. So for me, the pro outweighs the con, or the con outweighs the pro, or how you mean. And I even had a client, so there's a whole story here, where they wanted to do the classical ETL way, where I kind of forced them to do a ELT archive on the side, which at the end of the day, when they found out that they did some of the transformations the wrong way, I was able to tell them, well, let's go back to the ELT archive and backfill our tables with the history that you would have not saved if it wasn't for ELT, because it would have been chipped away, it would have been shaved up, it would have been outside of the box. So by loading in everything, we were able to go back and actually rescue a project that would have been otherwise half a year delayed if it wasn't for this archive. So question for this, I saw a hand raised and there are some minutes left. Was it Henry or Harry? I quickly saw someone flag. I guess not.
I can chime in. I see the question from Harry in the chat. The question is, would it be even cheaper to load Packet files into Azure Blob Storage if those files are accessible from Power BI?
Good question. Very easy to answer. It would be the same. Blob storage and data lakes are priced the same way. So it would cost the same. And basically, the most used part of the data lake is just a storage account, so a blob storage, with the added layer of having the so-called hierarchical namespaces, which is a fancy way of saying we can actually put a folder structure in it. So a data lake, as an Azure data lake, is only a blob storage with the folder structure, and that's oversimplified, but I think that's an easy way to understand it. Yeah. So same cost, blob storage, data lake, same, but data lake has more capabilities. So let's do a demo. I've lost track of time, to be honest. Can some of the organizers help me tell how many minutes we do have left? Because I'll adjust the demo accordingly.
We have
Mathias,
10
about 15
minutes or so, a little bit more.
A little bit more than 10 minutes. Okay.
Yep.
Perfect. Someone says, sounds like you're using ADLS Gen 2 Azure Data Lake. Well, if you go to the setting for ADLS, Azure Data Lake, sorry. If you create a new storage account, one of the settings will be, do you want to enable hierarchical namespace? And that setting will essentially turn it into what you call ADLS Gen 2, which stands for Azure Data Lake Service Gen, or Azure, sorry, that was wrong. Azure, I don't remember. Anyway, this is effectively a data lake. As soon as you enable that hierarchical namespace, it becomes a data lake. And I'm pretty sure that it even says that in that setting. It says like parentheses data lake or something like that. Anyway, so let's talk a bit about the tools in Synapse. First of them I want to talk about is the pipelines that we can use to ingest data, because I think that is a very cool and very powerful offering of the Synapse package. We are not going to be able to cover the whole package today, especially not with the time left, but we are going to cover the most essential ones, and pipelines is one of them. So with pipelines, we can do a cool thing. Not that much new to what we have in Power BI, but different. So I can go here and I can create something called the data set. And the data set is a kind of a template for my data source. So it's what is called a data source in Power BI. You can refer to this whenever you want to do a data load, and you can reuse this throughout different pipelines. And then I can make this data set dynamic by adding some variables, as I've done here. So I added these parameters, schema and table, and I added them into the setting of this data set, which means I can now define them at runtime. So if I wanted to load, instead of the customer, I want to load the sales details instead, I can just change it here. Oh, so sorry, guys. You see my screen now, right?
Yeah, better.
Better, but I need to do something. Okay. Thank you for speaking up. That would have been very awkward if you'd let me continue even longer. Perfect. And you're all with me again here, seeing the screen and all's good?
Yeah, looks great with that.
Good again. Okay, so I'll just show you here the data set. So the pipelines here, we can create these small activities that does something. They can load data and they can sync data. Especially this copy activity is important here. So we have the data set, we have some settings here like parameters, and we can add that to the setting, and that can be then utilized here under the actual runtime. So I can chase, if I want, instead of seeing sales details here, I can say I want to load the customer table instead. I can even go and preview if I hit the right data, and you can see now it is customer data. Then I can also go and define a sink. And this is where do I want to save the data? And I can do the same for a data lake definition data set. So I can go and add these parameters of which container to store it in, what directory, and what file name it should have. I add that as a parameter, and I can use it here. So I want to add it in my sandbox container. I want to use the directory here called supercharged / single load, and I want to call it customer. Okay. Can try to make it smaller. Bigger like this. So yeah, so I can suddenly define these on the fly, and that means that if I run this, it will actually run and start copying my customer data into this data lake, which is neat and cool, but it's not really the true power of why pipelines are really, really, really neat. Because this was just one table, one time. I don't actually put this on a schedule yet. Well, putting it on a schedule is as simple as clicking here and click add a trigger. And now I can make it do this every day. But still, it's one table from one database. It's not like going to be covering a lot, and it's a lot of work to just load one single table. So we can do more. We can go and do stuff like this. We can add a for each loop to the mix. So suddenly I can do something like a lookup here, looking up into a table. And as you see here, this is on the other screen. So just gonna do it like this. All right. Great. So I have the data lake here, and in the data lake, I have also added something that's called a storage table. This just works as a table. You can have had this in a database as well. So this is just for the purpose of the demo. Here I define some metadata, I define some sources, and I define some destinations. So all these data that I added manually before, I added them to a list here of metadata. And I can now do it for each loop that will then get these values as an input. And then on my copy activity, I can define this with a variable. So I can use the destination container value from that one row as my value. I can use it as my source schema and my source table. And I can use my destination container, my destination path, and my destination files from this metadata list. And I can use that for my pipeline, which means that when I now run this pipeline, it will start doing a thing, and it will load in some data. It will copy the data, and you see it starts copying all three at the same time. So around the same time it took to load one, we will now have loaded in 3 pieces of tables, and we only had to define it somewhere, one place. So when I need to add a new table, I can just add a new row to my path here and say, well, I want something like it to be on Sandbox. It should be my something table. And when I've added this row, well, then I just added a whole new table to my ingestion. So if I extend that and go add a bunch of tables like this, it will just work the same way. It doesn't matter if it's 1 or if it's 100 or if it's 1,000 really. So I just changed it to use this big list instead of the small one. And just this one change now makes this single pipeline go through a whole database and copy all the tables that I defined in my list. So adding a new table to your source becomes as easy as adding a row to a list. A very, very dynamic way to ingest data. Yes, absolutely. I even have went above and beyond in one case. I would not recommend this as a best practice ever. I just think it shows the power of what you can do. I even went and did a dynamic load of a whole server. So first I do a metadata lookup of all the databases in that server. Then I go through for each loop to execute another pipeline, which then looks up all the tables of that database. And it does that for all the databases, and then it runs the actual copy pipeline. So within like a 2-step pipeline here, I can run through a whole server, find all the databases, find all the tables, and copy all of them in a simple operation. So again, I would not go as far as to do the database dynamic, but loading all tables in one operation is a really dynamic and a cool way to load in data. So what happens when we have the data? We can actually go look at it here in our storage. So we have the sandbox here that we loaded the data to. We can go locate it. And we have something like here's Supercharge, and the data for today would be in 2020. So I added some sort of partition here for the date and the minute. And here we have all the data in Parquet files. I can go and I can use a SQL script on top of this data with the serverless engine. and I can actually run this SQL script. I just took a pretty random one here. As you can see, I actually query the data, and I could even turn it into a chart if I wanted to. So you can do cool stuff, but you can also do very powerful things like turning this this select statement into a view. We call it CPOC here, and we used the serverless thing. And now I suddenly turned the loading of my, I already had a view called CPOC in my database. Wow. So now we have a view based on the files in our data lake. And this was one file, but if I added like a dynamic parameter like this wildcard, it would have taken all the files in those folders. So again, we can make it a very dynamic way to have a view upon a bunch of files with a shared with some shared data. Basically, we could analyze the whole history of data, looking over all the files we ever loaded and stuff like that. The moment we do this, we can also start querying these things in Management Studio, in Azure, what's it called? Azure Data Studio and stuff like that. So the same query here, the view I just created, well, I can now query this in Management Studio. And you know what that also means? That means you are now also able to run direct query on top of your data lake files through this serverless view. So suddenly they start to be integrated more and more. You can start to utilize composite models in a way that was that is very neat and uses data lake as the backend. So very cool. But on top of that, we can actually we also have some direct integrations with Power BI. So I can add Power BI here as a workspace. I can go here and even tell it to create a new Power BI dataset. And it does kind of disappoint us here. It says, well, yeah, we can do that, but here, go install Power BI desktop, which is not ideal, but it does give us a help. If I click this is my serverless SQL and continue, it will actually give me a file with a connection to this serverless endpoint as a source to get started on, which is neat. So I could do that. I could use the tables I just created, the data I just loaded in with my pipeline, create a data set, upload it to the service, and have it like here, Supercharged demo. Having it here is a one click to start creating a report on the data set. And quickly I can start having something like, okay, customer analysis, sales, quantity, something. There must be a quantity. There, order quantity, and there you go. Within very small times, I've loaded in data to a data lake. I've created serverless layer on top of it. I've queried that layer through Power BI, created a data set, created a report on this data set, and I can even save this report back to Power BI. Directly from Synapse. Of course, creating a data set and creating a report would probably have been easier in the desktop, but nevertheless, it's something we can now do. And that was it for the demo. I want to sum up, because we're running out of time. I want to sum up and say, yes, the end-to-end scenario in Synapse is not very powerful, especially not for the modeling part and the visualization part. You could do things, but just not anywhere near as good as you can in Power BI. But that is also why we actually want to mix them together. So you can have your pipelines ingesting your data. You can have your even data flows in Power BI ingesting that data. There's actually an integration today in the workspace where you can say save data loaded with data flow in the data lake with that setting of your workspace. So you could even load it into your Synapse data estate from data flow. So you have this flexibility. Use the pipelines where you need these dynamic capabilities for big tables, or then maybe use Dataflow if you have an exotic REST API source that only works in Dataflow but doesn't work in pipelines, and so on and so on. You have the very, very capable data warehousing component in Synapse that just does this part really, really excellent and very cost effective and very powerful and very performant. And then you can utilize stuff like the data mart in Power BI, the modeling capabilities that are uncompetable for anything else, and the visualization capabilities as well. And then have your data stored in the data lake and as well as stored inside of Power BI, and use pipeline to orchestrate everything. I didn't show this, but you could even orchestrate the refresh of your Power BI. So everything can be tied together. You can run some pipelines. You can trigger the data flows from the orchestration of Synapse. You can do all your transformations. You can load them into a data set, and all of this can be controlled by the pipelines in Synapse as well. So you can really make sure that once you're starting to load data, they will land inside your data set the very quickest they can ever do. So that was it for me for today. I really enjoyed speaking here at your user group, and I am a bit sorry for going a bit over time. But I have enjoyed being here, and I hope you learned something. And I am, for one, open to staying longer to answer if you have any questions remaining. So just, thank you, guys.
Open mic, we have a little bit of 1 minute for any kind of open question. You can put that in the chat, or you can unmute yourself, and anything comes up from Mathias. This was an amazing presentation, Mathias.
Thank you.
Pretty enlightening in terms of the combination and what are the arts of possible between data lake, ingestion, Synapse, and Power BI.
Yeah.
Question from Harry. Any thoughts on ADLS versus Databricks for your data lake?
Okay, so Databricks, I think most of the implementations I've worked with and seen has still been using ADLS2 for the storage. So it's not about competing storage from Databricks versus storage in Azure Data Lake. It's about the compute engine. So in the Synapse world, in the modern data platform world, we actually decoupled storage and compute. And the storage is almost always data lake. And then you can have a data lake in Azure, or you can have a data lake in AWS. I think it's called S3 in AWS, and the same in Google's cloud. But then on top of that, you have a choice, because in Synapse, you have the engine called Synapse Spark, which has some capabilities. And then you have the other engine is Azure Databricks, or even Databricks from a different cloud vendor. So you have that choice of Databricks versus Synapse Spark. And that becomes a question of flavor. Databricks is, at this point, better for features. They are quicker at adapting to new standards for the Spark, the Spark, what is called, the Spark version, and adopting new features. But Synapse Spark is more tightly integrated with the tools that we also use. So if you're already Microsoft heavy, there's a big advantage of not having to add virtual networks and all these capabilities to your Databricks, but just have it inside that Synapse you may already use for your data lake and for everything. So yeah, it's a trade-off. It depends as always.
Awesome. I appreciate your time, Mathias. Thank you for the entire team at Champagne and the community around this. And we are going to upload this recording in 1 week after some editing and the videos to our YouTube channel. So thanks again for being here, and appreciate your time, Mathias.
You too.